Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. This is Maria Khan from Valeem.com. And in this video, as you can see the heading, we are going to discuss differentiation through chain rule. Over here, we will try to understand what are exactly the key points or the signs of the function after which we are going to decide that yes, this can be derivated or differentiated through chain rule. So what are the signs of those functions which are going to be handled through chain rule? So actually, whenever you are having a function within a function, then in that case, in order to find out its derivative, you have to apply a chain rule process. For example, if I just say that I just select a function, for example, f of x equals to x power 5, for example. Now, at the place of my base, I'm having a single variable x. Okay, this is a simple function. There is no concept of function within a function here. But instead of this, if I just use the same pattern of power 5, but at the place of my base, I use a long expression of some kind of some degree. It could be a quadratic expression, it could be a cubic expression, for example. So if I just say that I just assume that let y is a function in such a way that at the place of my argument I'm having this whole expression, okay, so it means that now my function is going to be written something like this. Okay, so how I'm going to derivate such kind of function where I'm having a polynomial within the polynomial? Okay, so for that purpose I'm going to assume that let this base, which is in the form of a full quadratic expression, let this base be equals to some other variable. Okay, I just say let it be u. So I just say that let u is equals to x squared plus 2x plus 3. Okay, so now my y is going to be equals to f of u, where u is actually a function with respect to the x, something like this. So now I'm having u inside f, so I'm having a function within a function. Now in order to derivate this function y with respect to x, how I'm going to handle this function within a function? So you see, I need to differentiate my y with respect to x, but at the left side it is, I have just written it quite swiftly, but at the right side it is not going to be that direct way. Okay, so what I do, I'm going to differentiate first of all my function f with respect to my u variable first. Okay, once it is sorted out, after that I'm going to derivate this u expression with respect to my original variable x. I hope you're getting the concept. So you see, this is it. So in other words, I can also write that d of f is first of all derivated with respect to u, and then this u expression thing is going to be derivated with respect to my x. Okay, so in that way this y can be differentiated with the help of my x. That's how it is interpreted. So you see, first of all you're differentiating with respect to u, and then you're differentiating with respect to x. So it is happening in sequential order. It's happening in the form of a chain. That's why you call this method as a chain rule. Okay, so chain rule, I repeat, is going to be used whenever you're handling a function within a function. Okay, so let's see a few examples here and try to understand the concept. Now here you see, I have just picked a quite simple example here. Now you can see that here my function f of x is actually according to a simple pattern of x power 4. Now at the place of my x, I'm not having just x, I'm having x squared minus 4. So you see, it is actually according to this form. It is actually something like this. Okay, so what I do, as I am not having a simple variable of degree 1 at the place of my argument of my function f, I'm having a full expression, I'm having a full polynomial here of degree 2. So what I do, I'm going to assume that let y u is equals to x squared minus 2. Okay, you have freedom, you can use any variable you want, but as we are quite habitual of using u, that's why we are just going with the flow, and that's it. So now my function y is equals to u power 4. Okay, now it is actually f of u. That's what it's entirely a rough thing. I hope you understand. So this is my equation number 1. That's what I'm going to assert. Now I'm going to differentiate both sides. Actually, I'm trying to differentiate with respect to x, but here at the right side I'm going to use a chain rule. So at the left side I simply write dy by dx, and at the right side, first of all, I'm going to differentiate this u power 4 with respect to u. Okay, so it's going to be 4u 4 minus 1. I'm using here simple xn formula if you are awake with this. So it's nxn minus 1. That's what I'm using here. So now, as this u was not the original variable, it was something that I have assumed, so I have to bring my original variable back. So I'm going to differentiate this u with respect to my original variable, okay, this thing. So now I'm going to replace my u with my original expression x square minus 2. So wherever I'm having my u, I'm going to write x square minus 2 there. So it's going to be x square minus 2 whole cube, and over here I'm going to take out the derivative, x square minus 2. So now it is going to be y prime. Y prime is actually the derivative of y, and that's how you interpret. So it's going to be 4 times x square minus 2 whole cube. Now you're going to apply your derivative on both these terms of this expression. First of all, u square and then 2. So you see the derivative of x square is 2x, and the derivative of this constant number is 0. So that's it. So now I just multiply my 4 with my 2x, and then I will multiply with my x square minus 2 whole cube. So it is giving me collectively 8x times x square minus 2 whole cube. You can expand this thing, but I'm not going to recommend that you should expand and take few more steps. There's no need of presently right now here. So you just stop your answer here, and this is said to be the derivative of this function within a function. Alright, that's it. So now let's see another example here. Okay, here you go, another beautiful example. Now you see here we are actually following a default function of f of x, which is actually our log x. Now at the place of my x, I'm having this full cubic expression. Okay, so at the place of my x, I'm having this full polynomial, cubic polynomial. So that's how my log function is going to be. Let me just slide a little left, so that let me just move a little here. Okay, so I could get my enough space to write. So it is now therefore log of x cubed plus 3x squared plus 1. That's what's actually the thing happening here. So you see, if I just assume that let my u is equals to x cubed plus 3x squared plus 1. Okay, so now my function is f of u is equals to log of u. Okay, so it is actually f of u of x, basically. I'm just writing two direct f of u. So you see, I'm having polynomial function within logarithmic function. Okay, the function within a function concept is now here. So we are going to use chain rule in order to find the derivative of this y. Okay, so let's begin. What we are going to do, we just say that let y is equals to log of u. Now this is my equation number 1. Now what I do, I just derivate my left side. I just write the differential operator d upon dx over here. Simple. And on the other hand, at the right side, I'm not going to be that much direct. I will first of all differentiate my log function with respect to our assumed variable u, something like this. Whatever I'm going to get, after that I'm going to differentiate this u with respect to my original variable x. Okay, so we know if you just see the list of your uh, of the derivative functions, you can see that the derivative of your log of x equals to 1 upon x. Okay, so derivative of log of u with respect to u is going to be 1 upon u, right? So it is going to be 1 upon u, and now I'm going to apply a chain rule on this u thing with respect to my original variable x. Okay, I just write y prime here, and then my y prime is equals to 1 upon, at the place of my u I just write x cubed plus 3x squared plus 1, and here I will take its derivative with respect to our x. Okay, and we are going to apply the derivative term to term here, so we are going to use xn formula as I have just written above in the previous example, you can see. So we are going to use that formula here, xn. So I'll be a little direct here because it's something quite basic. So I just copy this 1 upon x cubed plus 3x squared plus 1 as it is. Now I'm going to apply derivative on my x cubed, so it will be 3x 3 minus 1 plus 3 times, and now apply derivative on my x squared, so it's going to be 2x 2 minus 1 plus, then I apply derivative on my 1. So 1 is a constant number, and derivative of a constant function or a constant value is always going to be 0. So this is it. Now we just give it a final touch. So this is going to be 3x squared plus this is going to be 6x, and that's it, upon our x cubed plus 3x squared plus 1. You can either stop your answer over here, or much better if you just simply, if you further beautify your answer by taking a common variable outside on the numerator, which is possible here. The 3x is coming common outside here. We just take it out. Inside the bracket is going to be x plus 2. Now it looks much sensible now. So upon my nice denominator, and this is actually the derivative of my this function within a function, okay, polynomial function within the log function. So that's how we do. Okay, so I hope it's nicely understood. Now let's see one more example. Here you go. So you see now my f of x in default, my f of x is actually my sine x. Okay, now at the place of my x, if I just replace it with log of x, so now it's going to be sine of log of x. Okay, so you see I'm going to assume that let my log of x is u. Okay, so actually I'm having a logarithmic function within a trigonometric function. So function within a function concept is here. So let my u is equals to log of x, or u of x is equals to log of x. That's it. So my y is going to be sine of u. Now I'm going to differentiate, so I will write dy by dx, and over here I'm not going to be that much direct as I told you before. I'm going to differentiate first of all this function with respect to my assumed variable u, so it is going to give me cosine of u, and now I will derivate this u thing with respect to my x, because u is actually log x, so my original variable is x, so that's what I'm going to do. So it's going to be something like this. Now my y prime is going to be cosine of log of x, now I'm restoring the original form, times derivative of my log x. So as I told you that log x derivative is 1 upon x, so finally my y prime is going to be cosine of log of x multiplied by 1 upon x. Okay, so that's it. So your answer is going to be cos log of x, make sure that you are writing the angle inside the bracket, upon x. And this is the derivative of your function within a function, derivative of your logarithmic function within your trigonometric function. That's how you apply the chain rule process. So I hope that the concept of chain rule is somewhat clear to your mind. So if you want to join me and need to clear concepts of pure mathematics, mechanics, probability, or statistics, you can contact Valeem through these portals. Okay, so through these sources you can easily contact Valeem and they can redirect you towards me. Till then, take good care of yourself, practice well, score good. I wish you all the best in your future endeavors. Allah Hafiz, goodbye.